Hey guys, today we are representing just addition with different size parts. So again, our fractions would have different denominators. This is in your module 1 through 9 book, page 133. So we are flipping back to the other book now for a little while. Okay, so just like we did yesterday, we're going to represent them. We're going to use our tiles or our cardstock fractions we made. It's a good idea to be able to represent these, but as we are practicing and representing these fractions, you guys are going to start noticing, and probably just like that, y'all are going to be able to tell me some equivalent fractions, because you know when we're representing them with our tiles, we're just finding an equivalent fraction. And the more we practice with them, the more that you're just going to know those automatically. So we have the tiles now. We're not always going to have the tiles, but you're going to practice with them enough to where you get familiar and you don't even need them anymore. So have them close by while we're doing the work. Okay. So the first problem says Julia runs through an obstacle course. She climbs a cargo net in 1/4 of a minute. Then she crosses the balance beam in 1/6 of a minute. How long does Julia take to complete both obstacles? So it takes her 1/4 of a minute and 1/6 of a minute to complete both of those. For each of those, we want to know what it is for both of those. Okay, so let's represent that. Make sure y'all can see it. Yes. All right, I like to have my whole. I always like to compare it to that. And then grab a 4th. And we are putting them together. We're putting her 4th and her 6th together. So, a 4th and a 6th. When you're looking at these, you might think of a fraction tile that you have that they have in common. What you thinking? Maybe 12ths. I know 4 times 3 is 12, and I know 6 times 2 is 12. That helps me with this. 3/12 is 1/4. And I said 3 times 4 gives me my 12. And I know that 2 times 6 is 12. So 2 of my 12ths are equivalent to 1/6. And so we're just kind of looking at these and we're thinking of numbers that they have in common as we're counting by that number. 4, 8, 12, 6, 12. This is a number that they have in common, so this is how we can create that equivalent fraction. Okay. So instead of having 3/4, because remember what we talked about, just like if we had dogs and cats, you wouldn't say, I have 4 dogs and 6 cats, I have 10 cat dogs. That wouldn't make sense. We have to make them in a common way, like saying pets. So that's why we changed them to 12ths, so that they are both 12ths. They are both pets. So we have figured out that 1/4 is equivalent to 3/12. I always like to write mine underneath the one I made equivalent. And we have figured out that 2/12 is equivalent to 1/6. If I put those together, 1, 2, 3, 4, 5, that is 5/12. Another thing I like to think about is my fraction. Is 5/12 larger or smaller than 1/2? I know that half of 12 is 6. So I'm thinking that 5/12 should be smaller than 1/2, and it is. It's smaller than 1/2. And that's just something good to keep in our mind as we're thinking about our fractions. So she hasn't quite, it didn't quite take her 1/2 of a minute, which we know is 30 seconds. Okay? So there's that first one. All right, let's turn to the next page, 134. Okay, thought my video went out. Number 1 says some obstacles some obstacle courses include a rope climb. On his first try, Travis climbs 2/3 of the length of his rope. On the second try, he climbs more than his first try by 1/6. What part of the rope does Travis climb on his second try? First of all, good job, Travis. Have y'all ever tried to climb a rope? It's very hard. You have very strong arms. So let's think about what this says again. Remember, we don't need to just grab a number, do something. Let's think about what's happening here. So Travis climbed 2/3 of the length right here. And then the second time he does 1/6 more than he did here. See how he's a little bit taller than he was here? So we want to know how tall he actually got here. So 2/3, and he added a 6 to that. So we see that here with our tiles and our picture that they have. And do you see that they put that one hole just to help you have an idea of how it looks? Okay? So we've got thirds and 6. Let's think about it. What do you think we can use? I'm going to stick mine right here because ours look a little different than that. Just because ours are bigger, but I mean it's still going to represent the same thing. So here we have this. Okay, think about 3 and 6. You should think right then, well, those go together. And you're right. There would be 2 6 in every third. See how it perfectly fits? So if 1/3 is equivalent to 2 6. So remember, we've got 2/3 plus 1/6. So if there's 2 6 and 1/3, there would be 2 4 6 in 2/3. And I can stick them up here too for us just to make sure that's fine. Our 4 6 exactly fit there. So 1 2 3 4 5 6. When I add 4 6 plus 1 6, I get 5 6. That also makes sense because I was almost to a hole. And if I had my other 6, that'd be 6 6. Take one away, that's 5 6. Okay? One student used all his 1/6 fraction strips to find the part of the rope Travis climbed on his second try, and another student used all 1/12. Who is correct, and how do you know? All right, let's look back and see what it is it's saying. One student used all the 6, and one student used all the 12ths. Probably you're thinking, oh, yep, 2/12 equals 1/6. So the one that would be correct would actually be both of the students. And we know that because we said 5 6. Well, let's see how many 12ths that would be. 5 6, 1 2 3 4 5 would be equivalent to 2 4 6 8 10 12ths. So they are both correct. Could you use only thirds to represent the sum? Could you use thirds to represent the sum? Remember, the sum would be the answer. Remember, our answer is 5 6. 1 2 3 4 5. So here's a third, yes. Here's a third, yes, that's equivalent. But 5 6, you couldn't use a third because it's smaller than a third. So no, you could not, because it is too large. Write an equation to model your solution. We can write 4 6 plus 1 6 is 5 6. Woo. What part of the rope does Travis climb on his second try? Would be 5 6. Okay. Look at the last page. Or the next page. 136. Tina is making a vitamin drink to enjoy while training for an obstacle course. If she adds a half a cup of water to the mix, how many cups of vitamin drink does she make? Draw a visual model. So instead of drawing one, we're just using our tiles. You get my hole. She adds a half a cup of water to the mix. How many cups does she make? Let me see here. Oh, okay. I was on the wrong page. Alright, so we need to look at our picture. If this is 1 cup, and you can see that this 1 cup is split into 1, 2, 3 parts. 1 part, 2 parts, 3 parts. So that means inside of the cup already she has 2/3. So we needed to be able to look at the picture and see that. So she had 2/3 and she added a half of a cup. We need to see how much she's making all together. Let's think about what we could use for that. So I've got my 2/3 and a half. Oh, interesting. So, hope you're noticing that this is going to be more than 1. We can see that when we're representing it right here. I hope you guys can see it good. I think you can. So, I know that my answer is going to be larger than 1. Let's think about a fraction we could use. Remember, if we're counting by these numbers, we can tell. 3, 6, 9, 2, 4, 6. Oh, they both have 6 in common. Sorry, I keep adjusting them. We have talked about and realized that there are 2 6 in 1/3. And most likely, you guys know, there are 3 6 in 1/2. 3 is half of 6. 1, 2, 3 of them. This is going to be larger than 1, but I already know that 2/3, if 1/3 has 2 6, 2/3 is going to have 1, 2, 3, 4, 6. I'm going to write that below it. And we see that 1/2 is equivalent to 3 6. When we add them, we get 7 6. You may remember that a fraction that has a larger numerator than denominator is called improper. Okay, but all that means, let's look at it here, is that we used all our 6, which was 6 6, and if we have 7 6, then that means we've got 6 whole 6, so we made 1 whole thing, plus, let's stick right here, plus 1 more, and that made it 1 and 1 6. So 7 6 is equivalent to 1 and 1 6, because 6 6 equals 1 whole. You can see that right here. And we know that we had 7 6, so we're going to have 1 whole and 1 more. Okay? There's some more right here you can practice if you need to, and then complete your homework for tonight.